Plastic waste is a huge issue in the world, and our solution to this problem is, as I mentioned before, the recycler. So the recycler essentially would start here at this custom-made tool steel shredder. The individual will go ahead and wash the plastic piece, process it through this manually operated shredder, and as the pieces are appropriate size, they will go into this hopper here. The hopper will then funnel the plastic pieces into this chamber, which will have an auger bit driven by this geared motor, and it'll be funneled into this chamber here, which will be heated. And as the plastic becomes molten, it'll then extrude out of the nozzle at this point at about 1.75 millimeters in diameter, and it'll reach this area here, which will cool it. It's two cooling fans, which will cool it to retain its diameter, and it'll be then wound onto this spool, ready for 3D printing. And at the root of it all, we have this electronics enclosure, which will house the microcontroller to be able to control the geared motor as well as the heating element, depending on which plastic we're going to be using. Now, we calculated the manufacturing cost of the recycler is about $780.
Now, once we have the recycled filament, we'll be able to use a 3D printer and produce test specimens that are standard, that are by the ASTM standard D638 Type 1 for semi-rigid and rigid plastics. With this, we'll use the FAU laboratories to produce tensile testing, and we will gain properties such as the modules of elasticity, yield strength, ultimate strength, strain, to produce a safe and reliable product.
So this is the proposed hydro system design for this project. So we went with a design similar to the Pelton turbine because we want to use head elevation in order to run our turbine. Why? Because we want to implement this type of turbines in areas that they have rivers and high head elevation flow streams. So this design here, as you can see, has 5 different types of buckets. The way it works is it takes the impulse from the water in order to rotate the whole turbine, and when the turbine rotates, it's connected to a generator. This generator will then output enough power, hopefully to charge a battery. For now, our estimated power is about 4 watts from the rainfall. So it's not much, but with the battery, we hope we can save enough for future users.
All right, in order to optimize our designs, we will be using SOLIDWORKS as well as ANSYS software simulation software, and we will be conducting laboratory analysis on the recycled polymers and gathering experimental data from the FIU solar house as well as the portable energy unit. Thank you.
Okay.
Do you have any questions?
Hey, one quick question. Why 2 projects?
Excuse me?
I mean, I think you've got 2 projects here. One being the recycler and the other one being the turbine for the gutters. And why I ask it is that if you work one of those projects, you could get into the design stronger. You could get into the analytical piece of understanding your design. You can develop it, you can test it. You get into doing double, and that it just cuts in half the amount of time you have to be able to achieve those goals.
I feel that the reason we decided to do 2 is essentially because from the beginning of the summer, I had been working on this recycler on my own, doing a lot of research and parts acquisition. So it had already been a developing project on my own, and I joined their group, and they had already had this idea of a turbine, and we came up with the idea of being able to manufacture it through 3D printing. So it's not like the project doesn't have some momentum already. So I would imagine, yes, it would be much more difficult if it was starting from the ground up, but there definitely is some momentum.
And ultimately, we want to integrate all those parts into one unit. So we want to have the turbine, the pico-hydro turbine, the wind turbine from team number 3, and solar cells in order to have an overall energy benefits, some kind of house that can have a house running just on renewable energy. And also, the team here is going to be working on the waste. So we want to create this community that's going to be independent of like just the grid and be able to process their own waste.
Okay, I just want to highlight though, you need to do the analysis, you need to predict a solution, and you need to demonstrate experimentally that you can achieve, that you met it or did not meet that prediction. So that's still expected, and you now got 2 projects to do that.
Absolutely, understood.
May I see the schematic about slide 2 or 3?
Yes.
The overall project? That one? You're doing the recycler and the turbine at the end of the gutter, correct?
Yes.
What is the purpose of the turbine at the end of the gutter?
It's to collect, to harvest, well, once we have the rain gutter system, we'll be able to have some flow rate. And with this flow rate, we're gonna have an elevation, we'll be able to produce some type of energy generation through this.
Okay, this is to get energy.
Energy, yes.
Okay.
And it's also integrated to water filtration, which the environmental table will work on that after it gets down the downspout, pass through the generation of the hydro turbine.
And what will that energy be used for?
It could be used for various reasons, various parameters. Mainly, it could charge some batteries. The batteries are not
It's
sustainable
not
means.
designed to power the recycler?
No, it will not be designed to power the recycler. Even although it could go into a system where the energy generation can be captured, and then it could also be implemented with the power to power the recycler as well.
Okay. May I see the schematic for the recycler?
Yes.
What is the scale on that?
The scale is, I would say, it'll be about the size, slightly smaller than the size of this, the length of this table and about the width.
So what is the size of the input going into the hopper?
What is the size of the one, I'm sorry?
Of the input going into the hopper?
Oh, okay, so the actual plastic pieces, they can be the size maybe smaller than a nail.
And how does one obtain that type of input?
So let's say you have a plastic bottle, like Dr. Basil's, right? It'll be able to, this
Okay,
shredder will be able to
it's going to be
process.
shredding it, thank you.
You can constantly shred it, yes.
Thank you, you answered my question.
Any other questions?
Yeah, question.
Again, I kind of will reiterate a little bit about separate projects and things like that, but I mean, it is what it is, so that, I think it's okay. But you mentioned a little bit about self-sustaining, right? So in terms of the recycler, how is that self-sustaining? So for instance, you would have to go buy a bunch of water bottles, put them into, it's solely just a recycler, right? I mean, you're not gonna then continually recycle, are you, or?
Well, okay, so the idea I feel is within these communities that are just littered with trash, they will be able to collect that trash that's in their own backyards and clean it and process it into an agricultural tool or any sort of mechanical tool like a wrench of some sort.
I see. Okay, just the way I read your poster before, it made it seem like this was a project for, I don't know, Mars or something like that, where you build a house on Mars and everything is all self-contained and, you know, there's no input or output to that system. But I guess I read that wrong a little bit. But, so technically, you're just using whatever waste is around. So for instance, if this were in Antarctica,
It wouldn't work- it
It
wouldn't work
probably
as
is
well.
plastic bottle.
All right, I have
So,
a question. Was Dr. Basil finished?
Yeah, go ahead.
Could you refresh my memory on the global components? It did kind of hit me between the eyes.
Well, the global components are initially is just to provide some of mankind's most pressing issues, such as energy poverty, water security, sanitation, as well as the plastic waste pollution. So
Where is that in your slides? Maybe. Oh, there it is.
also,
So-
we also plan to train these communities with plan to make some manuals and provide some technical training for these communities that are willing to accept the training. We don't want to just enforce the aid on them, but we want the community to be able to be willing to accept this aid, so it's not something that's enforced like the traditional aid that has been used in the past.
Okay.
Can I do one more? So how do you guys integrate together? Are you making 3D printed parts for some of the filters and things like that? Or?
So the idea is, like they were saying, to do an integration of technical components that address these issues. So
Okay.
when you guys are saying, oh, there's several projects, it's not
Sure,
really
yeah.
like all of those many, because we are basically focusing on one at a time. You know, we're gonna focus on the building of the recycler first, then the manufacturing of the pico turbine. Where we come into play is in the water treatment, the water filtration, so the accessibility of clean drinking water from purifying it from the rain, as well as treating the waste generated by anybody, you know, that we do. So it's treated in a biological friendly way, so that this is like I said, a technical proposal, so that we have like a zero waste, zero net carbon emission project that addresses all these things through technical aspects.
Could your civil partners introduce themselves formally?
Yes, my name is Paola Davalos, environmental engineering.
Would you mind standing and introducing yourself?
Of course, sorry. Paola Davalos.
My name is Natalia Duque. I'm also an environmental engineering student.
I just wanted to highlight it real quick, and I've been on the committee for a long time. You've got a lot here.
Yeah, it's,
And as a result, you've also got a semester to get it all done in.
yep,
And we do expect data
of course.
and prediction and data to demonstrate that you met your prediction. You didn't.
Definitely.
That's where our concern comes from, is that we've seen a lot of projects,
Yeah,
and
They don't do it.
I don't want you boiling the ocean.
of course. So that's why like the main objective is the construction of the recycler that will be done, and you know, hopefully everything will be able to produce and intake 2 types of plastics and be able to produce the plastic filament out of these 2 different plastic types. When it comes to the actual Pico turbine, we're not really focusing on will we be able to have the integration into a gutter system. This is more of the design aspect, but as long as we're able to just design the Pico hydro turbine and like formulate the capabilities, the power generation capabilities, then we will be satisfied at that point and leave it like an open door for future research.
So what sort of prediction will be done on that? Are you going to track, so you're solely predicting amount of energy based on shapes of the turbine itself?
For the turbine, we needed to find a head elevation and a flow rate. They give me the rain gutter system, so from there I can design my turbine, because this turbine is designed according to specifications.
Okay, so you'll get a specific flow rate, and then you'll say, this should produce this exact amount of energy, and then we'll see it then.
That's why I have this
Okay.
size of the bucket.
Yeah.
And we're limited to use it on gutters because of our geographical location, but if we had a flowing river, then that would be, you know, continuous
Even better.
generation of electricity.
Okay, thank you very much.